Hello friends, welcome to Wisdom Training's MapReduce tutorial part 2. In the first part we have already covered MapReduce working in detail. So in this part we'll be discussing about MapReduce version 1 and why there was a need of getting MapReduce version 2. Alright, so let's talk about MapReduce version 1. We have already talked about this in the previous modules as well. But to discuss it here, to have a connect here, right, we need to talk it a little bit more here. Alright, so for that I'll just open up my notepad and I'll explain a few things about MapReduce version 1, right? Okay, so let's talk about MapReduce version 1, that is MRV1. So it has two software, two daemons, that is the very first one is job tracker and the other one is task tracker. So you have your single job tracker and you can have your multiple task trackers. So it is also based on the same master slave architecture, wherein you have one master, that is job tracker, and you can have multiple slaves, that is task tracker. Alright, so if I talk about job tracker responsibility and task tracker responsibility, I'll just draw them quickly, right? Okay, so this is my job tracker, right, and I can have multiple task trackers. So I'm denoting it as TT1, that is task tracker 1, and I can have TT2 and TT3, TT4, and so on. I can have multiple job trackers, multiple task trackers and a single job tracker. Alright, now so when a client comes, so he submits a job. So let's say this is a client here and it submits the application or the code here. Alright, so the client is submitting the application. Now what job tracker will do is it will allocate the task to the task trackers. Okay, so it will see, or it will create, first of all it will create an execution plan with which it will decide that which task has to go to which task tracker. Alright, let's say based on the execution plan it comes up with the requirement that it needs the application needs 3 map tasks and 1 reduce task. So this is the outcome of the execution plan after the analysis. Alright, now the job tracker execution plan, it will decide that which task has to go to which task tracker. So let's say it assigns, let me just change the color, right, so it assigns the very first task tracker a map task, similarly to second task tracker a map task, and same goes for third task tracker. Okay, so the very first 3 are given map task. Alright, and the last one is given, that is TT4 is given here reduce task. So when the client submits the application, job tracker's responsibility is to create the execution plan, that is it will decide which task has to go to which task tracker. Moreover, it will take care of scheduling the jobs, monitoring the job, or you can say monitoring the task, right? And so if there is a failure of some task, for example, let's say the very first task is failed, that is the task given to task tracker 1 got failed. So after a certain number of retries, job tracker will assign the task given to the very first task tracker to some other task tracker which is available. Alright, what do I mean by that? So if TT1 is not available, so the task will get shifted from TT1 to a task tracker, let's say TTN, if there are some other task trackers, in case of availability, based on the availability. Alright, so the job gets shifted, or the task is shifted to other task tracker. Alright, that is TTN. Fine. So in case of a failure, job tracker's responsibility is to shift the task from or reassigns the task to some other task tracker. So it does it if TT1 is down or the map has the map task has failed or any other task has failed. So this will be shifted to some other task tracker which is available. Alright, so this is about job tracker. Now if I talk about task tracker, so task tracker responsibility is to actually execute that task. So whatever task the job tracker is submitting to the task tracker, so task tracker's responsibility is to execute the task successfully. So this is the responsibility of task tracker. So there comes job tracker and the task tracker. But there were certain issues in MapReduce version 1. If we talk about the limitations here, I'll just write the limitations here. There was underutilization of the resources. So what do you mean by underutilization of resources? For example, if a task tracker is given a map job or a map task, it cannot it cannot suffice to some other task. For example, here only if I have a single application, let's say application A is there. So if application B comes and it asks for the resources or the tasks or the task trackers, and if they are already having some task in hand, they cannot compensate the tasks for application B. So this was a major issue in MapReduce version 1, that is, it can take care of one task at a time. For example, if they're doing a map task, they won't cater to the tasks of the application B, right? They won't cater the task of reduce task, right? So in that case, there was underutilization of resources. So what do you mean by the resources here? Resources, I can say you can talk what do you say is resources? So resources can be a memory clubbed with CPU, clubbed with disk, and network bandwidth. Alright, so these are the resources that you can club. Okay, so memory, CPU, disk, and network bandwidth clubbed together can be called as resources. Alright, so for example, if I talk about TT1, it has 6 CPUs and 6 GB of RAM. Right, okay, and 6 GB of hard disk and all. So if a certain map task requires only 1 CPU and 1 GB RAM, let's say, and only 1 GB of space is required. Okay, so rest of the 5 CPUs and 5 GBs are underutilized. You cannot compensate, or you cannot assign that resources to some other task. So this was a major flaw that was existing in the MapReduce version 1, which is being taken care in the MapReduce version 2. Alright, so the underutilization of resources, so it was if you have map tasks, more number of if map tasks are full, reduced tasks are empty, and if reduced tasks are full and map tasks are empty, in both the cases there was underutilization, because you cannot assign other tasks to some other task tracker because of this flaw. Alright, then you have resource management, and processing done by single entity. Wherein you have your different entities for both resource management and processing in MapReduce version 2. So this is a kind of overhead if both the things are to be done by a single entity. For example, if a job tracker only takes care of both the resource management and the processing, so there is overhead on the job tracker. Whereas this issue is being taken care in the MapReduce version 2, where you have 2 different entities for that stuff, right? So let's talk about MapReduce version 2 right here, right? So I'm just going to the slides first. So it consists of a job tracker and one task tracker per cluster host, right? So job tracker is responsible for just scheduling the job components on the task tracker host and monitoring the task and re-executing the failed task that we already spoke about. and task tracker host executes tasks as directed by the job tracker. So the task tracker responsibility is to execute the tasks that are given by job tracker. And here if you see in the picture, your job tracker and the name node, that is HDFS, they run on a single node. And if you talk about task trackers and data nodes, they run on different nodes, that is slave nodes. So you have your one master where your job tracker and name node runs, and you have slave nodes where your data nodes and task trackers run. Alright, so this is a basic or high level view of MapReduce version 1. Right now, so MapReduce version 1 has three main components that we have to see now. So it is API for user level programming of MR applications. Another thing that I missed telling you in the MapReduce version 1 flaw, there's another limitation here. So MapReduce version 1 was only available for MR applications. You can only write MR applications, but you cannot interact with known MR applications, right? For example, you have something called as graph, and you have something called as Tom and Spark, right? Wherein with which those are non-MR applications, and MapReduce version 2 has been made to interact with known MR applications as well, wherein this thing is not possible in the MapReduce version 1. So this is another kind of limitation that exists in MapReduce version 1. Okay, so three main components are API and the framework and the resource management, that is infrastructure to monitor nodes, allocate resources and schedule jobs. Okay, there were issues here. So inflexible configure nodes, that is either map or reduce, not both. So underutilization of clusters where maps are more, reduces are more. Resource sharing with known MR applications are not possible, that we already talked just now, right? Now if you're moving from MapReduce version 1 to MapReduce version 2, there's some error here. It should be MRv2, correct? So if you see in the MapReduce version 1, there is API, there's framework, resource management. So all the things, right? So this is framework will take care of the processing, and resource management is taking care of the resource management itself, right? So no resource management component. Now this both resource management and processing taken care by single entity, right? Whereas if you talk about MapReduce version 2, so this is my MapReduce version 2. MapReduce 2, this part, this will take care of only processing, whereas Yarn API and resource management will take care of only resource management. So resource management component Yarn will take care of resource management, whereas MR2, that is MR API and framework, will take care of processing only. So you've got two things here. You have only one thing here which was taking care of both the things or both the functionalities, whereas you have two different entities. So which one is better? Obviously the MapReduce version 2 is better, because you have different entities and there is no overhead on a single entity, right? Now, so the solutions to the issues of MRv1 are given by the Yarn architecture. Alright, now we need to discuss about Yarn here. Okay, so Yarn is yet another resource negotiator, right? And let me just write it here. So let's talk about the Yarn architecture. You have two daemons, three daemons actually. You have your global resource manager, you have your node managers, and you have application master. Alright, so I'm repeating, per application master, that is application specific application master. So here if you see, it is also based on some kind of master slave architecture, wherein your global resource management is your master. So this is my master, and here comes my slaves. Alright, now let me draw and tell it to you. So this, let's say I have this resource manager. and I have same stuff exists. You have your single resource manager and you can have multiple node managers. So I'm going to give it a name as resource manager, and this is your node manager, that is nm1, nm2, nm3, right? So you have your resource manager and you have node managers. Alright, now when a client submits an application, so this is my client, it submits an application, so it has an application specific application master. So what happens is, in the very first go, you have your application master, so it needs to run, so it needs a resource to run upon. So that resource is called as container. So container is a unit of basic unit of allocation of resources, right? So application master needs resources, that is, it needs a container to make itself functional. Okay, so when you submit an application, what will happen? A container will be assigned on a node manager. So this here is a container. I'll just change the colors for the container. Okay, let's say this is a container that is assigned for the application master to run upon. Okay, so the application specific application master is there. So now application master has got the container to run upon. On the reboot, what will happen? It will register itself with the resource manager. Alright, so application master registers with the resource manager. What happens, why do it register is, so once it has registered with the application application master registered with the resource manager, client can directly ask resource manager what is the status of the app master, where my jobs are, what is the status of my jobs, and what is the status of my application that I have sent you or that I have submitted to you. Alright, so therefore the app master registers with the resource manager. So once it is registered, it again asks for containers from resource manager for the actual application to run upon, right? So it will there's a protocol that is called as resource request protocol. So there are two different things, right? First of all, resource manager assigns a container for application master itself to run upon. Then app master, once it is registered with the resource manager, it pings resource manager that I want containers for my actual application, that is where my actual application will run. So it is done through a protocol that is called as resource request protocol, wherein application master asks resource manager to provide some containers where the actual application will run. So what will happen, resource manager will assign certain containers. So let's say it assigns containers here on nm1 and nm3, right? So where the actual application will run. Right, so these are the containers where the actual application will run upon, right? And also this was the responsibility of, or this is a, you can say the role of resource manager to assign the containers. Now there is, what is the role of node manager then? So node manager's first role is to assign the containers, because the containers are being assigned from the node manager itself. Resource manager tells that you have to go to this node manager. I mean, again, kind of execution plan, that is resource manager will tell that you have to go to nm3 or nm4 and nm5 and so on, right? Whatever managers are available, right? So the resource manager's duty is to inform or tell that on this node manager you will get the resources. So actual responsibility of node manager is to provide the resources, so they provide the resources or containers. Okay, another thing what they do is, node managers, so they tracks the status of containers and tell it to resource manager. And update to resource manager about the status, right? So this is a two-way stuff that happens here, correct? So in this way they report to resource manager that this is the status of resource or the container and job, right? Now once the application is completed successfully, the resource managers the application containers that have been assigned to the application, they will be returned back to the node managers, right? Or they will be released. So containers are released after the successful completion of app or job. Alright, so application containers are also released, and once the application containers are released, application master also releases the container that is assigned to it. So this whole resource is available back now. And in case if there is another application that comes, if another client comes and submits an application which is called as B, right? So now as we have discussed, this is an allocation of containers, so there will be no problem. So what resource manager will do, it will assign another application first of all it will assign a container for application master, and then similarly after that it has got the application master for B, I'm going to write it here AMB, that is application master for job B, right? So once it has got the container for application B, then it can also assign the resources here or the containers for job B as well. That is, resource management is taking very effective here, because this is a container only, that is it will be using certain number of CPUs and RAM and network bandwidth, right? And the rest of the resources which are available can be assigned for some other job. So I can write here an app B, and that is app B runs here. Right, so in this way it is taking care of resource management very effectively. Alright, so I repeat, when client submits an application, resource manager, what it does is it assigns a container for application master, and you have per application master. So application master is assigned a container, then application master registers with the resource manager, and then with the help of resource request protocol, it asks for the containers for the actual application to run upon, and actual applications, once they are finished or completed successfully, releases the containers that are assigned to them. And after the successful release of the containers from application, app master itself releases its containers, and resource is available back again. Alright, so this is about resource manager, application master, and node managers. There is another term called as application master itself. So there are two terms. One is application manager and application master. So application master we have discussed. Now is the turn for us to discuss application manager. So application manager, it runs on resource manager itself. So here it runs. So application manager runs on resource manager. It takes care of the submission of the applications by the client. So when a client submits the application, that submission process is taken care by the application manager, and moreover it also negotiates with the resource manager for assigning the container to the application master. So it does both things. So you have four stuff here that we discussed. That is global resource manager, you have your node managers, and you have your application master and application manager. Right, so this is all about yarn architecture here. Right, now let's move back to the slides and see if we have missed something. So application master handles most of the functions of the job tracker. There can be multiple application master for a cluster. So yarn daemons, you have resource manager, so which runs on the master node, and it's a global resource scheduler, that is, it assigns the resources for the application to run upon. Alright, and it also deals with the node manager, that it takes care of the heartbeat signal. So if there is a heartbeat signal, it knows that the node manager is alive. So it tracks the heartbeats from the node managers and handle AM requests, that is application master request for the resources, and deallocate containers when they expire or application execution is complete. So all this we have studied. Right, if we talk about the node manager, they run the save nodes similarly, that similar to the one in the MRV1, because you had task trackers which were slaves, and here you have node managers which are acting as a slave. So they communicate with the resource manager and get the containers assigned, and the actual application is run. Right, so what does node manager do? So it registers and provides info on the node resources, sends heartbeats and container status. So we have already discussed that it sends the container status and the job status as well. Now manages processes in containers, launches AMs on request from RM, that is launches application master on the request from the resource manager, launches application processes on the request from the application master, and monitors resource usage by the container, kills runaway processes. So once all the containers or all the applications are finished, they'll kill away the processes and release back the resources that were being given to an application. Correct. So you have containers. So we already discussed a certain portion or a basic unit of allocation of memory, CPU, disk, and bandwidth or network bandwidth. Right. Yarn application execution flow. There is a job submission by client, then job initialization, task assignment, memory assignment, status updates, and failure recovery. So if you see here in the yarn cluster we already talked about, you have got your resource manager, you have got your node managers. When a client 1 it comes, it submits an application A, then resource manager launches the application master. Alright, and then application master using the resource request protocol asks for the containers on the node manager. So it assigns to it has assigned containers for actual application where the actual application will run. Right, so once the application containers are assigned, application is executed or launched by the application master, and in between if there is another application, that is application B comes. So for same way, resource manager launches the application master on the node manager. Similar request is gone for the containers, and app B is also run. Right, so this is about yarn cluster application flow that we already discussed in detail. Right, now coming to the life cycle of a job, you got your client, resource manager, app master, and node managers. Let me just take a simple line here. So first step is you submit a job. Right, client submit a job here, so submission of job is done. Then resource manager, it says application node manager that I need resources for the application master. Then node manager assigns the containers for the application master, and then application master further asks for the resources from the resource manager, and then the node manager assigns the actual containers for the actual application to run upon. Right, so this is something so once that is done, the containers are released, application master containers are also released, and client in between keeps on asking resource manager whether it is done or not done or not. So once it is completed, then it says yes, it is okay, it is done, and your application is completed successfully. So this was about a life cycle of a job in yarn. Right, so next part you will see when you buy the videos. Right, so you've got quite good learning of MRV1 and MRV2. Right, and more MapReduce in detail. Thanks.